Hey everybody, in this video we're going to go over the 7-4 trig identities version 1 of the worksheet this year, and it says established identity. Hope everybody's having a good day. So the first thing is you have tan u minus secant u equal negative cosine u over 1 plus sine u. And it says write the left side in terms of sine and cosine. So what you would do is look at your trig chart. You have a quotient identity that has tangent as sine over cosine. So this needs to be sine u over cosine u. And the next one says secant u. So you look at your reciprocal identity, and it's 1 over cosine. 1 over cosine u. Then it says simplify by writing it over a common denominator. You keep your cosine on bottom, and then you put sine u minus 1. And then it says rewrite the expression by multiplying the numerator and denominator by sine of u plus 1. So basically the opposite. So what you're going to do on this one is say sine u plus 1 over sine u plus 1. And they don't want you to distribute the denominator. They just kept it that way. But we do want to, distribute or use FOIL to your numerator. So the denominator is going to stay the same. And the numerator would be sine times sine is sine squared. Then your outside is positive sine u minus sine u, and then minus 1. So here's where you need to remember your Pythagorean identity. Sine squared plus cosine squared equal 1. And so if we solve for cosine squared, that'd be 1 minus sine squared. So on this, it looks like this, except for they're in a different order, and so we need to multiply by negative 1. So I need to factor out a negative sign and make it 1 minus sine squared u over that same denominator. I just put denom right there. And so now that it looks like it's in the same format, I just put my negative cosine on top. And that's what they want. Well, this one was sine squared u minus 1, and this one is negative cosine squared u. So after we multiplied it, that's what we get. And then write the numerator in terms of cosine. So instead of having sine in the numerator, they want you to use it in terms of cosine, which is why we use the Pythagorean identity. And so then this one asks you about the fraction, then simplifies to that using what? So basically we would cancel the u with this, and so that's the cancellation property. Okay, on our next one, we have 4 cosine minus sine squared plus 7 cosine plus 4 sine squared equals 65. So it says rewrite the left side by removing the parentheses. So they basically want you to expand it. And these three terms come from that. So basically 7 squared is 49, so 49 cosine squared, and then you get 28, and then you gotta double it to get 56, and then 4 times 4 is 16. So that's what they got there. On ours, we need 4 squared, which is 16. 16 cosine squared theta. And then you get, just like this other one, 28, but then you double it and you get 56. And then negative 7 times negative 7 is positive 49 sine squared. What you should notice, for those that just like to look at patterns, you have a 49 sine squared and a 49 cosine squared. And so I'm jumping a little bit ahead, but it says you're going to factor out the common term. So, okay, so this is your answer to this one. And then it says rewrite it by combining like terms, and that's where you're going to cancel your 56 and the negative 56. And so you have 16 cosine squared plus 49 cosine squared. So just think of that as 16x plus 49x, and that'd be 65. So you get 65 cosine squared theta plus 65 sine squared theta. Because again, you're doing 49 plus 16 is 65. Okay, so here we're just going to factor out a 65. And we get cosine squared theta plus sine squared theta. And that then simplifies to 65 using the Pythagorean identity. Since cosine squared theta plus sine squared theta equal 1. So that one's Pythagorean identity. So your numbers are going to look alike when you have a problem like this. They just had 4, negative 7, and then 7, 4. So like I was saying earlier, you know, if you have 16 here, then you're going to have 16 here. And your 56s and negative 56 are going to cancel. And if you have 49 there, you're going to have 49 here. And then you just combine your like terms. 16 plus 49 is 65. And then you just go from there. Factor out the 65. And then substitute this and turn it into 1. Okay, on this next one we have simplify the numerator by applying the appropriate Pythagorean identity. So our Pythagorean identity involving tangent is this. It's 1 plus tangent squared theta equals secant squared theta. And so now to solve for tangent squared, we subtract 1. So we get tan squared theta equals secant squared theta minus 1. And that's actually what we want right there. Then they want you to factor the numerator. So think of this as the difference of two squares. And so you get secant theta minus 1, secant theta plus 1. The order does not matter, but basically split it up. And to check it, secant times secant is secant squared. Then you have secant minus secant goes away, and then -1 times 1 is -1. And you know you're on the right track if this cancels, because it then simplifies to secant. What's happening is this cancels with this, and then you do 1 minus 1, which also cancels. And so this would be the cancellation property in simplifying further. So cancellation and simplifying further. Okay, on our next one it says get a common denominator, and so we're going to have tan theta 1 minus secant theta for our denominator, and for the numerator we're going to have 1 minus secant theta, which was already there, and we need to multiply it again. And then on this one we have minus tan theta, and we've got to put tan theta over here too. So now that'd be what we want for our they want you to simplify this a little bit and then put it in here. It says do not expand the numerator. So this would be 1 minus secant theta squared. And then this one would be minus tangent theta squared. And so we're going to put the squared in the middle. Now they want you to expand, so on this one you go 1 squared is 1, then you got a negative secant minus another secant is -2 secant, and then plus secant squared. So that's from expanding. Now what they want you to do is use a Pythagorean identity. And so the one that has tangent and secant is this one, 1 plus tangent squared equals secant squared. And so we're basically going to change secant squared to be 1 plus tangent squared. So we have 1 minus 2 secant theta plus 1 plus tan squared theta, and then over here was minus tan squared theta. So these are going to cancel. Tan squared minus tan squared cancels. And then 1 plus 1 is 2, and so you get your 2 minus 2 secant theta. And if you get it to that point, they're going to want you to factor out a 1 minus secant. Factor out a 2, and then you're left with 1 minus secant on top. And then they want you to cancel that, and you get 2 over tan, which is 2 over cotan. 2 cotan. Because your reciprocal identity is, if it's 1 over tan, or if you have tan x, it's 1 over cotan. Cotan x is 1 over tan. And so if it's over tan, then it's just going to change to cotan. So we get it from canceling this, so that'd be the let's see, cancel out the like terms, and then simplify it by using the reciprocal identity, which was 1 over tan equal cotan. So this 2 over tan then simplified to 2 cotan from this reciprocal. Okay, on this one, multiply and write it as the difference of two squares. Cosecant times cosecant is cosecant squared. Then your outsides and insides cancel because a positive and negative are the same thing. And then you're going to get minus cosecant theta cotangent theta. Plus cosecant theta cotangent theta. So really these cancel. And then minus cotangent squared. So we basically just have cosecant squared minus cotangent squared. And your Pythagorean identity involving this is 1 plus cotangent squared equal cosecant squared theta. And so if we keep the 1 where it is and move this over, we get cosecant squared minus cotangent squared, which is exactly what we got, and so that's from the Pythagorean identity. Okay, on our next one it says write the left side in terms of sine and cosine. And we have cotangent, so you use your quotient identity for cotangent, and it's cosine over sine. And then change your tangent to be sine over cosine. Then they want you to simplify that. And write it in terms of sine and cosine. So what we would want for this one is to get a common denominator. And so this will change into cosine theta times another cosine theta. And then on this one we have to have our sine theta times another sine theta to make it a common denominator. And so this ends up being cosine squared theta plus sine squared theta. And then that's equal to 1. So that's how you end up getting 1 over sine theta cosine theta. So it's from these extra steps. Get a common denominator, and then square them, and then that Pythagorean identity. Simplify the expression and write in terms of sine. So here your cosines are going to cancel basically. So you get 1 over sine. And then that simplifies to cosecant using the reciprocal. Okay, so number 7, it's telling you to multiply it. So you want to do sine times 1 is sine. Sine times cosine is sine cosine. And then do FOIL. So 1 times 1 is 1. Cosine minus cosine cancels, and so then you get negative cosine times cosine is cosine squared. So again, this is where you need to remember your Pythagorean identity. And so sine squared would be 1 minus cosine squared. And so we have sine theta plus sine theta cosine theta over sine squared theta. So this looks like one where I really should not have multiplied the numerator out. I'm just going to factor out sine so that it would cancel. So your sine cancels with the 2. And so then after all that, you get your 1 plus cosine theta over sine theta. So remember, when you're canceling these, if it's sine squared, only the 2 cancels with the sine. Okay, next, write the left side in terms of sine and cosine. So cosecant would be 1 over sine. And then write that as a single fraction, so that'd be cosine over sine. And then that's cotangent using a quotient. That's one of the easier questions right there. So we have cosecant is 1 over sine, then just put these like that, and then that's the quotient identity. Okay, number 9, this one, cosecant is 1 over sine, and cotangent is cosine over sine. And so then you're multiplying your outsides and insides. In other words, your sines are going to cancel, so you get 1 over cosine. And it says rewrite it in terms of sine and cosine, and so that's all you get. Don't change it to secant. Okay, and on this one, they're going to want you to factor. Let's factor the denominator first, because then that'll help us with the numerator. Like, if I look at the numerator, I could have used 12 with 1, 6 with 2, or 3 with 4. And I can pretty much tell I'm going to need 3 with 4 based on my denominator. So let's do our denominator first. And we've got a 1, and our middle term is positive, so we just do plus 1 plus 1. Then check it, 3 cosine squared, and then you have 3 cosine plus cosine is 4, and then 1 and 1 multiplies to get 1. Now, again, what I was saying was, if you do your denominator first, that's going to help you know what to put for your numerator. So just put something exactly like it. And then let's just figure out what needs to go here. We're trying to get 12, and we've got 3. So 12 divided by 3 is 4. So we need 4 cosine theta. And then we're trying to get 1 for our outside. So 1 times 1 is 1. And then just check it. 3 cosine plus 4 cosine is 7 cosine. And so then this cancels. So we get 4 cosine theta plus 1 over cosine theta plus 1. Okay, on this one it says write the left side in terms of sine and cosine, and we have cosecant. And so that would be like 2 times 1 over sine. And then secant is 1 over cosine. And then they left this side the same, and then they put 5, or they kept the 5 cotangent. So this part changes to 2 over sine, and this part changes to 1 over cosine. So then what they want you to do is multiply your 2 times cosine, you get 2 cosine, and multiply your sine times 1, and that's sine. So now both have common denominator sine. So here you're just going to do 2 cosine plus 3 cosine gives you 5 cosine over sine. And then that goes to cotangent using the quotient addition and a quotient. So the quotient was the cosine over sine. Alright, number 12. Write this over a common denominator. And so we have cosine sine as our denominator. And this side is going to need sine. And this side's going to need cosine. So then from there, you're going to want to distribute sine times cosine, and then minus sine squared. Then distribute this part. You can have minus cosine sine, or since this was in the order with sine first, I'm going to put sine first. So sine cosine. The reason is because now you can see that's going to cancel out. If you're multiplying, the order doesn't matter for your 2 terms. And then this will be minus cosine squared. So our next step would be factor out a minus sign from these 2 terms. And then that changes to 1 from the Pythagorean identity. So negative 1 and then cosine theta, sine theta. Again, it doesn't matter if you put sine then cosine. That doesn't matter. Okay, then number 13. Which of the following 4 statements establishes the identity? Okay, so this is where we have a cotan of a negative. So this would be your even-odd identity. Cotan of negative is negative cotangent. So negative cotangent. This changes then to 1 minus cotangent squared theta equals cosecant squared theta. So if one of them was negative cotangent, then we got 2 of them, so it's squared. Oh, I should have said plus a negative right there. That wouldn't be for the answer. 1 plus a negative cotangent squared, and then that changes to 1 plus cotangent squared, which is cosecant squared. 1 plus cotangent squared is cosecant squared. So you just do your substitution and work that. Okay, on our last one, multiply and simplify that. So we keep our numerator the same. And then you do sine times sine is sine squared. And minus, well, okay, so you're going to have minus sine cosine minus another one, gives you minus 2 sine theta cosine theta, and then plus cosine squared. Okay, so then we want to use the Pythagorean identity where this and this really is just 1. Like that. And then we want to distribute a negative sign. And then this one cancels, and then the sine cosine cancels with this sine cosine, and so you end up with 1/2 for your answer. Alright, so that's the video with 7-4, the example 1.